This is Math 10150 Lesson 1, and in this video we will review equations of graphs and lines. You should have seen equations of graphs and graphs of lines before, but it is important to review it because in the next classes that you will take in pre-calculus and calculus, it is very important to be very quick about graphing lines and manipulating equations of lines. So a line graphed in a Cartesian coordinate set looks like this, and it is enough to know 2 points on a line to graph the line through it. So for example, if we know our line goes through the points x1, y1, and we know that it goes through the points x2, y2, we can figure out the equation of the line completely. The most important thing about the line is its slope, and slope is the rise over the run. It is the difference of the y coordinates divided by the difference of the x coordinates. So this vertical distance, the rise, this vertical distance is the difference of the y coordinates. It doesn't matter what you choose to be your first point and what you choose to be your second point. And the horizontal distance is the difference of the x coordinates, the distance between x2 and x1. And this gives you the slope, and then the equation of a line can be written down in several formats. So the slope is most often labeled by the letter m, and by far the most popular format of a line is the slope-intercept form and the point-slope form. So I'll write the point-slope form first. So the point-slope form of a line is y minus y1 equals the slope m times x minus x1. So if you know the slope m and you know a point that your line goes through, you can readily write the point-slope equation of a line. The most convenient form is the slope-intercept form. It is very convenient for graphing. This is the y equals mx plus b form. Very often when you're asked to write down the equation of a line, it is the y equals mx plus b form that you're asked for, the slope-intercept form, where b is the y-intercept. The y-intercept is the place where your line intersects with the y-axis. So this point on the line is 0, b. That's the slope-intercept format. Another format where you can be given the general form of a line. The general form of a line you can be given like this: ax plus by equals c. The general form of a line is not really good for much, so if you are given a line in this form, you usually want to convert it to the slope-intercept form. Another useful thing to remember about lines is the sign of the slope. Lines that go up from left to right have positive slope. And lines that go down from left to right have negative slope. So when you are faced with writing down the equation of a line, you should not hesitate to go back and forth between the general form, slope-intercept form, and point-slope form. If you're given 2 points, as we'll do in the next problem, if If you're given 2 points, you should not hesitate with how to write down a line that goes through these 2 points. Okay, so let's do an example. In example 1, we are asked to find an equation of a line through the points -2, 5 and 4, -3. So we are given 2 points. We cannot jump into writing down the equation directly. We first need to figure out the slope. It is useful to write down label every single coordinate point as x1, y1, or x2, y2. So this point, the first point, is x1, y1. The second point, 4, -3, is x2, y2. So now we're going to compute the slope of our line. The slope is going to be y2 minus y1 divided by x2 minus x1. So in our case, y2 is -3 and y1 is 5. It does not matter which point you choose to be which. We could have chosen the point -2, 5 to be x2, y2, but once we make the decision, we have to stick with it throughout the problem. And x2 is 4 and x1 is -2. So another common mistake is to mess up the minus signs here. It is minus x1 and minus y1. So if we have a coordinate with a negative coordinate, we have to subtract the negative number. So on top here we have -8. On the bottom we have 6. If you want to simplify that into most reduced form, the slope is -4/3. So now we can write down our equation of the line. We're going to write it down point slope first. Once we have a point and our slope, our go-to equation is the point slope form. So here we have y minus y1 equals m times x minus x1. Again, you can choose any point. You don't have to choose x1, y1. You can choose x2, y2 as well. It doesn't matter. So we have y minus 5 equals our slope, which is -4/3, times x minus -2. So technically, in this problem, we're asked for an equation of a line. We were not asked to simplify it or to put it in point slope form. So technically, at this stage, this is an equation of a line. If we wanted to simplify it and put it in slope-intercept form, we are going to have to get into, I'm going to have to do some more simplifications. So y minus 5 equals -4/3 x plus 2. Y minus 5 equals -4/3 x, and I'm going to distribute this term. I'm going to get -8/3. And we're going to add 5 to both sides. Y equals -4/3 x minus 8/3 plus 5. To put things over the same common fraction. Denominator, -4/3 x minus 8/3 plus 15/3. And finally, our slope-intercept format of the line becomes y equals negative 4/3 x plus 7/3. So our final answer in slope-intercept form is this. We were asked for an answer in point-slope form. It would be this equation. So when you are given 2 points and you want to construct a line, the first thing you do is write down the slope. Once you figured out the slope, use any of the 2 points, write down the point-slope form of a line, and then if needed, simplify that to the slope-intercept form of a line. In the next problem, we are given to write in slope-intercept form and graph the following line, 3x plus 4y equals 12. So this line is given to us in general or standard form, and if we want to graph it, the absolute best thing to do would change it to slope-intercept form, since slope-intercept form is the friendliest for graphing. So we have 3x plus 4y equals 12, and we want to convert this to slope-intercept form. So we isolate y on one side. So we have y equals 3 minus 3/4 x. To write it in completely standard notation, I don't have to, but I could write it like this. This is y equals negative 3/4 x plus 3. This is the slope-intercept form of the line. That's part 1 of the question. This is the slope-intercept form. Because we can find the slope and find the intercept from this form very quickly, the slope is negative 3/4, so the rise over the run is negative 3/4, and the y-intercept is the coordinate point 0, 3. So now, when we are tasked to graph this, the very first thing that we will plot is the y-intercept, and then figure out the slope, and then graph the rest of use the slope to graph the rest of the line. So the y-intercept is at 0, 3, which is here, and now we have a rise of negative 3, which means we have a fall of 3, so 1, 2, 3, and we have a run of 4, 1, 2, 3, 4. And so our next point on our line ends up here, and then we just draw a line through our 2 points, and here we have it. So the rise was negative 3, and the run was 4. We could have also thought about this as a rise of 3 and a run of negative 4, and then went the other way. But anyway you choose is fine. I prefer to put the negative number with a rise, because if there's a rise of negative 3, that means there's a fall of 3, and it's more natural to graph that way. In the next example, we are asked again to write in slope-intercept form and graph the following equation of a line, minus y minus 4 plus 3x equals 0. So this is given to us in a sort of standard form. This is still an equation of a line. The power of y is 1, the power of x is 1, and there's a constant, so this is still a line in the plane. So our very first step is to convert it to slope-intercept form, and we're careful with the signs here. Again, we want to isolate y on one side, so we have minus y equals negative 3x plus 4. And then we multiply both sides by negative 1, and all the signs change into y equals 3x minus 4. So this is our slope-intercept equation of the line. From which, as the name implies, we can get the slope, which is 3, and the y-intercept, which is 0, negative 4. And when we are graphing this, we will start by graphing the y-intercept. The y-intercept is 0, negative 4, which is here. And now we have a slope of 3. You can also think of this as 3 over 1. A rise of 3 for a run of 1. So we have a rise of 3, 1, 2, 3, and a run of 1. So we end up here. And our line looks like this. So the goal for this course before you start pre-calculus is that you're able to manipulate equations of lines very quickly and to not hesitate when you need to graph a line.